last class we have discussed about the Epsilon NFA to NFA. We will see one more example on Epsilon NFA to NFA conversion. So here the given question that we have the Epsilon NFA, that is non-deterministic finite automata. Simply we have seen the P2Q we have the epsilon, and again P2R we have the epsilon. Whereas the epsilon that contains only in the NFA, so whereas in the DFA there is no epsilon conversions. So here first we will find the epsilon closure for all the states. That is the first step, epsilon closure for all the statements, epsilon closure of P, epsilon closure of Q, epsilon closure of R. We will see the epsilon transition from the P first. So from the P, from P to Q we have the epsilon transition. So whenever we are finding the epsilon closure, so first the same state itself, that means whenever we are finding for the P, we will write the P as it is, the same state. So P to Q, again we have the epsilon, so we will write the Q. Again we will see from P to R we have the epsilon transition, P to R. So from P, so we have the R, so write down the R. So next go with the Q. So we look on the Q state, we don't have any epsilon transitions from the Q. We have only the C and the B transition. We don't have epsilon transition on Q. But we have to write the same state itself, Q. Next we have epsilon closure of R. So from R we don't have any transition. So we can't give it as the phi. So because the same state itself, we can write it as the epsilon closure. So that is R. So this is the step 1. We have to find the epsilon closure for all the states. We have P, Q, R are the states. So we have to find epsilon closure of P, epsilon closure of Q, and epsilon closure of R. After finding this step 1, so whereas we have to convert these epsilon closures to the NFA. That means we have to remove the epsilon. So first we will find the formula for the indirect transitions. Delta dash of any state. Q means state, comma alphabet. A is the alphabet. So that is epsilon closure of delta, delta dash. Delta is the direct transition. Delta dash is the indirect transition. Whenever you are performing delta dash of Q comma epsilon, that means epsilon closure of the Q itself on the input alphabet small a. Like that you have to perform the indirect transitions. That means we have to perform the indirect transition not only for the single state, we have to perform for all the states as well as for all the input alphabets. So we will perform delta dash of P comma. So we have the alphabets A, B, C, right? So delta dash of P comma A. That means we have to do for delta dash of P comma A, delta dash of P comma B, delta dash of P comma C. Same like that we have the input alphabets A, B, C. For the state Q also we have to find Q comma A, Q comma B, Q comma C. Same like that. So we have the one more state, that is capital R, R comma A, R comma B, and R comma C. So we have to find all these transitions. First we will start with the delta dash of P comma A. So that means whenever we are performing this indirect transition, so apply the formula epsilon closure of, so delta dash of, what is the state? P. So we are performing on the epsilon transitions, right? P comma epsilon on input alphabet A. So now epsilon closure. So according to the delta dash of P comma E, P comma epsilon, so delta dash means epsilon closure itself. So epsilon closure of, for which state? P. P comma A. Like that we have to apply the formula. That means, so now epsilon closure of delta of epsilon closure of P means, so here we have written epsilon closure of P, right? So that means P comma Q comma R. P comma Q comma R is the epsilon closure, comma on input alphabet A we have to find the transition, so we have to write the A. That means delta is the direct transition from P comma A. Like epsilon closure, we will apply the union. That means we have the delta dash of P comma A union, delta dash of Q comma A, delta dash of R comma A. Oh, delta dash of P comma A. We will apply for P, Q, R on input alphabet A. So we are writing with the union operation here. So next, we will find what are the direct transition from P comma A. P on input alphabet A, we will check. P on input alphabet A, we don't have any transition. So just mention it as Y. Next Q. Q on input alphabet A, we don't have any, we have the transition for the P. So write it for the P. And R. From R we don't have any transition. So mention it as phi. That means delta dash of, epsilon closure of phi union P union phi means that is P itself. Epsilon closure of P means, so that means P comma Q comma R. This is the result that what we obtained here. The same like that we have to perform for delta dash of P comma B. That is P comma B. So write down the formula for epsilon closure of delta dash of P comma epsilon comma B. That means epsilon closure of delta of epsilon closure of P comma B. Epsilon closure of P, we know that P comma Q comma R. So just apply that delta of P comma Q comma R on input alphabet B we are finding. Same epsilon closure of delta of P comma B union delta of Q comma B union delta of R comma B. That means we will check the direct transition on delta of P comma B. P on input alphabet, that is reaching to Q here. Q on input alphabet B, so the transition for R. And R comma B, from R we don't have any transition, just apply B. So whenever we have the two states in the epsilon closure, we have to write epsilon closure of Q union epsilon closure of R. This is very, very important. So we have to perform for both. Epsilon closure of Q means Q union, epsilon closure of R means R. Q union R, that we will get Q comma R. So we have applied P on input alphabet A, P on input alphabet B. Next we have to go with the P on input alphabet C. That means directly you can write it as epsilon closure of delta of epsilon closure of P on input alphabet C. Epsilon closure of delta of epsilon closure of P means P comma Q comma R comma C. So epsilon closure of delta of P comma C union delta of Q comma C union delta of R comma C. Now check the transition on input alphabet C. P on input alphabet C we have R transition. Q on input alphabet C we have the self transition for the Q itself. From R we don't have any transition, just mention it as phi. So now epsilon closure of R union Q. So epsilon closure of R union epsilon closure of Q. Epsilon closure of R means R itself. Epsilon closure of Q means Q. That means we have Q comma R is the delta dash of P comma C. the same. So we will write the transition table. First we will go with the P comma A. We have obtained the result as P comma Q comma R. P comma B we have obtained the result Q comma R. For P comma C, so same, that is Q comma R. So next we have to apply for delta dash of Q comma A. So we will write for Q comma A. So we will write for delta dash of Q comma A. That means epsilon closure of delta dash of Q comma epsilon comma A. That means epsilon closure of delta of epsilon closure of Q comma A. What is epsilon closure of Q? So epsilon closure of Q is nothing but Q itself, Q comma A. Delta of Q comma A. Q on input alphabet A. We don't have transition. That is 5. So epsilon closure of delta of Q comma A is 5. That means 5 itself. Same we have to apply for epsilon closure of Q. So we will see for epsilon closure of Q on input alphabet B. That is epsilon closure of, so here delta dash of Q comma B means epsilon closure of delta dash of Q comma epsilon comma B. That means epsilon closure of delta dash of Q comma epsilon means epsilon closure of Q comma B. So that means epsilon closure of delta of epsilon closure of Q means Q. Input alphabet we have only B. So Q on input alphabet B we have R. Q on input alphabet B we have the transition R. Epsilon closure of R. What is epsilon closure of R? That is R. Same like that we have to perform on input alphabet C. That means we will get it as epsilon closure of delta of, directly I am writing here, delta of Q comma C. So delta of Q comma C. Delta of Q comma C is Q on input alphabet C. We have transition to the same self state, that is Q. Epsilon closure of Q. What is epsilon closure of Q? That is Q itself. That means, so delta dash of Q comma A we have 5, Q comma B we have R, C we have Q. Same apply for delta dash of R comma A. Delta dash of R comma A, that means epsilon closure of delta dash of epsilon closure of R comma. So that means delta of epsilon closure of R on input alphabet A. So here epsilon closure, delta of epsilon closure of R means R itself, R comma A. R on input alphabet transition we don't have anything, right? So directly we can write it as 5. Same delta dash of R comma B. From R we don't have any transition. Again we will get the same epsilon closure of delta of R comma B. So that means delta of R comma B. Again it is 5. So that means we will get the result as 5 itself. again delta dash of r comma c. So that means we will get it as epsilon closure of delta of r comma c. That means again we have r comma c. From r we don't have any transitions. That is phi itself. So we will get it the phi. So write the answer. So this is the second step. First we have to identify epsilon closures. Next we have to go with the indirect transitions for all the input alphabets with all the state transitions. After that we have to move to the third step. That means we have to draw the transition table as well as the NFA diagram without epsilon. Means the given question is NFA with epsilon closures, but we have to convert without epsilon. So move to the third step. So draw the transition table first. So like input alphabets A, B, C on P, Q, R. P on input alphabet A, we reach to P comma Q comma R. On input alphabet B, Q comma R. On input alphabet C, that is again Q comma R. This we call it as the transition table. Q again, Q on input alphabet A phi, B we have R, Q on input alphabet C, Q. Next R on input alphabet A, B, C, all are phi because we don't have any transitions. So again we will perform delta dash of Q comma A once, because delta dash of Q comma A, that is epsilon closure of delta dash of, so here epsilon closure of Q on input alphabet A. So epsilon closure of Q is Q comma A. What is Q comma A? Q comma A we have P, right? Epsilon closure of P. Epsilon closure of P means that is P comma Q comma R. So sorry, first we have to write here P Q R, we will get it as P comma Q comma R. That means here the table we will get it as P comma Q comma R. So now check it. So what is delta dash of Q comma C again? Q comma C means we have Q state itself. So again we have the transition for A also. So delta dash of Q comma C, epsilon closure of delta of epsilon closure of Q comma C. Q means Q comma C we have two transitions, epsilon closure of delta of, so we have Q as well as P, P comma Q comma C. That means epsilon closure of, so delta of P comma C union delta of Q comma C. So delta of P comma C, so delta of epsilon closure of delta of epsilon closure of Q comma C means, so Q on input alphabet C we have P and Q. That means epsilon closure of P union so epsilon closure of epsilon closure of P union Q. Epsilon closure of P is P Q R, Q is Q comma R. That is we will get P Q R. So that means the here Q comma See, that is not only P, so we will get it as PQR. So don't forget this transition. So that means here we will get it as PQR. So now draw the transition table. So after getting this, we have to draw the transition table. After transition table, we have to draw the NFA. So now P, Q, R. Now we will draw the NFA. From P on input alphabet A, we have P, Q, and R. Next Q. So P on input alphabet B, we have Q comma R. On input alphabet B, we have Q comma R. Next on input alphabet C, Q comma R. So on input alphabet C, Q comma R. Next Q on input alphabet A, we have P, Q, R. So again Q on input alphabet A, we have P. On input alphabet A, we move to P, Q, R. On Q on input alphabet B, moving to only R. P, Q on input alphabet C, we have P, Q, R. So that means P, Q, R on input alphabet C. Same. Q on input alphabet A, so we have moved to P, Q, R. So B on input alphabet B only to R. C on input alphabet on state Q, A, P, Q, R. Next R, we don't have anything, we have all the pi's. So again given in the question, R is the final state. R is reached in the epsilon closure of P comma Q comma R. So now make P as the final state. So this is the resultant NFA. So first we have performed epsilon closure of P, Q, R. Then we have to move to the transitions of finding the indirect transition. Delta dash on input alphabet P, P comma A, P comma B, P comma C. And again we have the Q, Q comma A, B, C, and R we have A, B, C. From R we don't have any transitions, directly we can apply it as the phi. From P, so we have to find the transition, indirect transition, applying the epsilon closure formula. So now we will get all these results. After finding the step 2, we have to go with the step 3. So taking the transition tables. So after transition table, we have to draw the NFA based on this transition table. So that is about the conversion of epsilon NFA to NFA.